In this question, I want to show you how to avoid being scared by these big numbers. Exponents raised to big powers, thinking you have to do all sorts of work. You don't. It's going to be based on one simple rule with divisibility. We're going to see that very clearly in the solution. So let's check it out now. All right, this is a super fun one here. Looks a little scary, right? The remainder when 3 to the 16 is divided by 2. 3 to 16 seems like a big number, right? And then the remainder in quantity B, the remainder when 4 to the 15 is divided by 2. Again, this looks like a pretty big value. This looks like a pretty big value. Now, there is such a thing as remainder patterns if you need to use them, but we don't here. We need to recognize, hey, wait a second. We're just dividing by 2 here and 2 here. And what do we know about quantity A? Well, we know 3 to the 16 will always be odd because 3 itself is an odd number. No matter what exponent you set it to, it's always going to remain odd because an odd times an odd is odd. What do we know about an odd divided by 2? Well, the remainder is always going to be 1. And then same with quantity B. Wait a minute, 4 itself is even, so 4 to raise to any power, or 4 to the 15 for that matter, is even. Of course, we know an even number divided by 2 is going to give us a remainder of 0. Notice we didn't really care about the exponents. We didn't do a ton of work. So we know that since the remainder in quantity A is 1 and the remainder in quantity B is 0, quantity A is greater than quantity 1. So A is our answer.